So, welcome back, everyone. If you had a good weekend. So this is our final webinar in our four-part webinar series. We're going to dive into some of the more intermediate, borderline advanced in some cases, programming on the Sysmac platform. So the agenda isn't as big today because each of these is going to take a bit longer to go through than some of the stuff we're doing in the previous days. But we're going to cover importing a library into your Sysmac Studio. These are available from Omron. We're going to go over UDT, or user-defined data type creation. We're going to go over some custom function block creation. And then we will do a PID programming example. And I will email you guys a file. Actually, you're on a different version that may or may not work. We'll see. I can walk you through building your own anyways, but we'll do some PID programming. So I'll get you guys to open up the program that we were working on. Okay, so what I'm going to do is I'm going to post a website address in chat, and I'll get you guys to go to that website. It's an Omron France website, so some of it's in French, but it's got the library that I'd like you guys to install in it. So I am going to send this address now. So you guys can navigate to this page. If you open it up in Chrome, it translates and it looks a bit better. So what this library is Mqtt. Some of you are probably familiar with it. It's a communication protocol that we can do. So a lot of our protocols come in the form of a library. So some of our Modbus libraries, I know Mike, you've played around with some of those. And if they come from us, they've got support from us and they've got documentation from us. So the actual library file in here is the fourth one down. So I'll get you guys to download this file. And it's got an SLR extension on it. And if you guys want, you can also grab the manual for that library. There's an English version with an E at the end, so it's not all French. I'll give everyone a minute to do that. If anyone's having any difficulties with it, just let me know. I could email you it if your network's blocked it or something like that. Okay, so now back in Sysmac, we're going to go up into project. Well, make sure your PLC is selected first off. If we do this on the HMI, it's going to be looking for an HMI library or an IAG, they're called. But in the PLC, if we go into project, library, show references, it opens up our library reference window. So in here, we can add that library that we just downloaded. Mine got put in my downloads folder, so there it is there, Mqtt. Click open, it's going to import it. It may warn you about a version. Let's see. Okay, so just click OK if it warns you about some version compatibility. Basically, it says versions older than 1.18 might not work with this library. So if we expand it here, we can see what's included in this library. So it has a few function blocks and it has some custom data types that we'll be using, and you can actually preview them all. No, this one doesn't have any data types. That's just expandable. So it's got 2, 4, 6 different function blocks that we can use. And we want to make sure that this checkbox is selected here. Include the referenced libraries into the project. It should be by default. So click OK. Now you'll notice in your toolbox over here on the right, we now have this Mqtt library in our toolbox. I'm not going to play around with it too much, but it lets you drag and drop what was included in that library into your program. So the reason I chose the Mqtt one was because it's available just through a web link. Now, if you guys are familiar with our Sismac Library, the one the Omron Americas does, I'll just navigate to that here. We have a library for a lot of different hardware. So I'm just gonna punch this in my web browser here and show you guys.
Also, just a quick note for that toolbox to show up with the Mqtt, you just have to have the program open, like the ladder.
Yeah.
You guys are having trouble seeing that.
Yeah, so we have what's called Sysmac Library, and this one requires you to register with the website, which is why I got you guys to download the one from Omron France. But what's cool about this is we have libraries for everything you see here, our drives, some of our Slice.io, HMIs, SQL, displacement sensors, vision systems, servo drives, pre-programmed blocks for both the PLC and the HMI to simplify your programming. So I just want to give you guys a quick tutorial on how to get set up with a library and also where you'll find them. Truthfully, I just Googled Sysmac Library and got here. They're pretty easy to find. They are free. You do have to register with the website. That's all. So. Now we will dive into what are called UDTs, or user-defined data types. So most of you are probably familiar with these in other platforms, or if you're Sysmac users, you may have played around with it already. But for those of you who haven't, what a user-defined data type is a grouping of different variables that we treat as a single piece of data, and we can access the members of that data type one at a time. So I'll do an example here, and then we're going to come back here near the end after we make our own function block, and we're actually going to make a data type to go with our function block. So our parent member, if we go here into, sorry, I should walk you through this as I do it. So under programming, under data, we have data types. And in here we have three options. We have structures, union, and enumerated. So what we want to do is called a structure. That's a custom data type, a UDT. We won't be dealing too much with union or enumerated. So the first member available to us is going to be the name of the data type. So the data types we've been working with have been integer is the data type, or Boolean is the data type. We're going to make our own data type. So this is where we decide what we're going to call that data type. Like I said, we're going to come back and build one a little later, but I'm going to call this example DT, and then we create a member, as many members as we want, and we name those members. E1, for example, E2, these are Booleans, B3. Now when I make a variable of that data type, I choose example data type, and then when I'm using it in my actual program, I can reference all of those members that I created. That was my test UDT dot, and I've got all the members that I created. So those of you who haven't used these before, they're really good for reusing your code. You could make a data type specific to a VFD. You can make a function block specific to a VFD. And now you've got one function block, you've got one data type, and you can repeat the process on your HMI and pair it with this data type for ease of programming. So we'll come back to that. So I should have switched the order in my PowerPoint there. But we'll actually do a custom function block now. So like I was explaining to you guys a few sessions ago, I think on day 1, we have functions and function blocks. And up until now, we've been using the pre-canned kind of comes with the software function blocks. You guys are familiar with a lot of these from other platforms, timers, counters, that sort of thing. But we can make our own, both functions and function blocks. So if we go to our programming section, down at the bottom, we've got function blocks. So I'll get you guys to right click on it, go to add, and add a ladder function block. And we're going to rename this function block by right clicking on it and choosing rename. And we'll call it VFD control.
Is everybody good? Everybody's got to this point?
I don't see anything in chat, so
Good.
double click on VFD control, the one you just created, and it brings you to a blank programming canvas that you're familiar with. And up at the top, we're going to drop down the variables menu. And you can see we've got a few different options here now. So in our normal programming interface, we have internals and externals. Well, here we have internals, in, out, and externals. So what these mean are, it's similar to the internals and the externals don't mean the scope of the program. It means if they're exposed externally to the function block. So if we had a timer in here and we didn't need to know the value of that timer outside of this function block, then we would make that an internal timer. In-out variables, now these are the ones that you see exposed on the outside. So these are the ones that you can map data directly to. So I'll throw that Mqtt function block back on here just to show you guys what I mean. You don't have to do this. So everything on the left-hand side here, topic, QoS, buffer, RCV topic, message. So these would be input variables. So they will pop up on the left. And then everything on the right-hand side here, these will be output variables. Externals, so these are going to be existing global variables in your PLC. So if you had an emergency stop bit that was referenced everywhere in your project and you didn't want to do anything if the plant was in an emergency stop state, we could actually go directly to that global variable by entering it here. So I'll choose a yeah, this one's fine, just as an example. So I can put that one in there. And now I don't have to map this mysterious gibberish variable from the outside world to the block. I can just reference it directly. So this would be, like I said, if you had an emergency stop or if you had a plant state variable that you had to track and you didn't want to map it to every single instance of every single block, you could save yourself a bit of time by just pointing to it directly. Now, word of caution here is this exists in my PLC, but if I were to make this function block to control a VFD, I exported this function block out of my PLC and passed it off to my coworker to use in his plant. He probably doesn't have this variable in his PLC, so that would give him an error. It's pretty easy to correct, but it's just something to keep in mind when you use externals. If you export them or if you use them in a new project, then you need to make sure that all of these references to external variables exist in whatever controller these function blocks are used in. Okay, so now we'll make some variables. We'll start with the in-out variables. So this is a VFD control block. So the first one we'll make is going to be start. Our next category is in/out. So is this an input? Is this an output? Or is this an in-out? Input, I showed you, they show up on the left-hand side of the block. Output, they show up on the right-hand side of the block. In/out is a variable that shows up on both sides of the block. On that Mqtt block, I believe there is one, and I'll show you what that looks like. Yes, so buffer here, you can see it exists on both sides. And if I were to just enter the name of a variable here, so that showed up, I typed it on the input and it showed up on the output. So this is for passing a variable into the block, and then the block passes the variable out. So if you were doing an averaging of a large array of data and you just wanted to spit that data out when you're done with it, you could make that an in-out variable instead of having one input for that and one output for that. Very useful in some cases, a bit confusing in others, but we won't need that in our function block. Okay, so we'll make start an input. We're going to add a few variables here, so I'll just type them. I'll stop at the end. Give you guys a second to catch up. If you have any problems, punch them in chat or speak out. Okay, I'll give everyone half a minute to catch up there. Just speak up if you're having any issues. Okay, so now before we actually start building our block, let's go to our program and let's see what that actually looks like in the real world. So go back to your program 0, section 0, and we're just going to add a rung below. And now we can punch the name of the function block we created. Nope, sorry, that's only if we make a library out of it. So we know the name of the function block we created because it's over here. We haven't made a library out of it yet because we haven't programmed and debugged it and exported it. But if we were to actually finalize this and turn it into a library that we could share with others, we could actually have it pop up right in our toolbox here. So for now, I'll get you guys to right click on the rung and insert function block. If you're a hotkey programmer, just press F. And we're going to type the name of the function block that we created, VFD control. So as you can see, all of our inputs are on the left-hand side, all of our outputs are on the right-hand side. Because it's a function block, we will need to give it an instance name, but we'll come back to that in a bit. I just wanted to show you guys what that looked like. So let's go back into our function block itself. We can close the variables, actually keep it open, just so you know what you named everything. So now we're going to do our best to basically mimic the programming that we've done up until this point. So start push button or the start signal will latch the drive. Stop signal will unlatch our run command to the drive. We'll have an accumulation timer. We'll have some fail to start logic in there. But the good part is, being that it's in its own function block, we can cut and paste this function block as many times as we need to. This is probably quicker for one motor to do it this way, but if we had 10, even 5 motors in a plant, it's much quicker to just build a function block and reuse your code over and over again. So I'm going to program here. I'll go fairly slow. You guys can just follow along with me, and I'll stop at the end, let everyone catch up.
Hey, Stu, I have a question for these custom function blocks.
Yeah.
Can you force an output for any of these variables that you're creating in the simulator? Or sorry, like an input or an output for any of these variables? Do you have the ability to force those to something?
We can set and reset them like we would a variable in logic, yes.
Okay.
But for forcing them like we would an IO point, it would be that wouldn't work. Like if I tried to force on run output, or if I hit set on run output, you know, that's going to be dependent on what precedes it, sort of thing. So we have the same simulating and testing capabilities within the function block that we do within our ladder logic. But forcing it like an output doesn't work on either front unless it is an actual output. Does that make sense?
Yep, yeah, for sure.
Yeah. Oh, so here's a good example. So I just realized that I didn't make an input variable for my run feedback. So I'm going to create a new one here. A Boolean is going to be an input, and this will be my run feedback. Sure. Actually, no, I don't want to use that because it's already taken. So I'll just say run FB feedback. Sure. You guys may have noticed I made a function block in there, gave it a name, and that automatically populated it into internal variables in my internals, externals, and out variable section at the top here. It put it into internals. So if I wanted to, I could move it to global, but I really don't need to know the details of this accumulation timer at the outside world. All I really care about on the outside world is the variable called runtime, which is an output variable already. So I have no problem getting that to the outside world.
What was the reason for the bool on the reset?
Oh, I put bool pound false.
Yeah. Is that no reset for that timer? Just constantly running?
Yeah, it's, I don't know, it's more of an OCD thing with me. I could leave that blank if I wanted to. It's
Okay.
false by default. That's just more of an OCD thing with me. I like to populate all input parameters, but I could just leave it blank. It defaults to 0. So
Oh, okay.
I'm also trying to drill into people how Omron does constants versus other people. So you have to specify the data type name and then pound and then the value.
Okay.
Same with the timer here, T pound 10,000 days. So Okay, I'll give you guys a second to catch up there. I'm going to, hold on, it's not happy about something. Yeah. So hopefully you guys didn't make this same mistake. When I made my alarm reset, I didn't choose the data type. So if yours happens to be integer, you can change it to bool.
I was just looking at that, trying to put the alarm reset in there, and it worked for you, but for me, if I had it set as an integer, it wouldn't allow me to make that. It like wasn't populating for a variable on the contact.
Okay.
I guess that's for good reason. If it's not a bool, it
Yeah,
won't actually come up.
it generally only autofills the same data type. Yeah. Okay, so if anybody needs a little bit more time, just speak up or just type 1 more minute in the chat or something like that. Good. So this is a not a piece of logic you would probably use in the real world, but we haven't really commented anything up until this point. So let's I'll show you guys how to actually comment all your logic. So we right click on the run number. There's an option to edit run comment. So you guys can type a few comments in there if you want, just as a reference. I'm going to just kind of point form comment each line here. I worked with a programmer who refused to comment his code. one time, and he said it was hard to write, so it should be hard to read.
That's a quote for the books.
Yeah. There's another one for you, more of a programmer joke. What's the definition of an algorithm, Chase?
The definition of an algorithm? I don't know.
It's a term used by programmers when they don't want to explain how they did something.
That's not a bad one either. That's the secret sauce right there. Custom algorithm.
Yeah. Okay, so I had some comments there. Now I'm going to make an instance of this function block, if you guys haven't already. Rung. Right-click anywhere, choose Insert Function Block, or click on the rung and press F, and then just type the name of the function block, which is VFD control. Oops. I'm going to make two of them. So I'm actually going to just cut and paste that whole rung. Or actually, no, I'll do it on one rung. Doesn't really matter. So now we need to do two things here. We need to name our function block, and we need to assign some variables, create some variables and assign them to the actual function block. So our first VFD block will be P1000 per second function block. Just don't double click on it, just single click on it. Will be P2000. And now we can go to the inputs, and you guys can copy the variables that I add there. So we'll stop at the end, give you guys a chance to catch up.
For the run FB, you'd want to call that P1000. Just a little typo there.
Oh, good catch, yeah.
Is there a way to auto create these variable names if you had like a bunch of pumps?
Yep, and I wanted to do it the tedious way first to make everyone appreciate that much more, because that's what we're doing next. So I did this on one run. I'm gonna just drop it down onto 2. It doesn't like branching after outputs, only before. So quick fix. There you go. So give everyone a minute to get caught up there. Okay. I'm going to assume everyone's all caught up. If you need another minute, just speak up. Otherwise, I'll press on here. So what we'll do now is do a quick simulation of what we've done. So you can go up to simulator. We won't run it with the NA simulator this time. We're just going to run the PLC simulator. And we want to just verify our function blocks working right. We want to verify we can control these pumps individually, or these VFDs individually. We don't know they're pumps, but we'll pretend they are. Okay, so I'm going to turn on my first VFD. And I should see it trip in about 3 seconds because it doesn't have run feedback. So that worked, and I have my alarm output on. So I'll reset my input. I still have my alarm, so I'll set and then reset my alarm reset input. Now I use the same variable for both of these on alarm reset. I could have actually mapped the external variable right to the block if I wanted to, but in the future I may want to individually reset these instead of try to reset both of them at the same time, so I just left that as an input variable. Now we will give it run feedback and start it again so we don't get the alarm. And now we should start seeing our runtime going up. We can also verify that it latches. Now we can make sure it unlatches. Okay, perfect. Now, if there was a mistake in this block, one thing that is very nice in Sysmac Studio is we can actually edit this block online. So double click on it, and it brings you to the base object of this block. Now, we can edit this like any other section of logic. Start the online edit, and let's say I wanted to make my fail to start timer 5 seconds now. I can hit enter, send my changes, and now every single instance of this function block is updated to that new time set point. So it's actually one thing that sets us apart from a lot of platforms is we can edit our custom function blocks online. Now that being said, I will make you aware of some restrictions with that. So we can change logic and we can work with variables that we've already created in our online edit. But as far as creating in-out variables up here, it is something that we can't do. We can add a new external variable and we can create a new global variable in our PLC to go with it. But we can't modify our in-out variables, only our internals and our externals. So if you forgot that you'll need to map, you wanted current monitoring as an output and a current limit set point as an input on each drive, that's something that you couldn't do individually for each drive. You would have to go offline, make that change, and then retransfer your program. So right now, these function blocks they're in different states right now. This one, I've given it a start command. There's no runtime accumulated on it. And this one is just sitting idly, ready to go. Now, if I want to look at the individual contents of each individual function block, you can right-click on them and choose Go to Lower Layer, or just double-click on them and you'll see the individual instance of that function block. And Chase, this is where you would do any debugging on an individual function block basis. So this one here, for example, I know that I've tripped the fail to start alarm. So I can go into it here, see the status of just this block. So there's my alarm.
Oh, okay, very cool.
So I can, just like ladder logic, I can reset it, and it's only going to affect that instance, the P2000 instance. P1000 is untouched because I wasn't looking in that one. So.
Every time you go into a simulator, like my speed is like super quick. If I set something to a second, it's like a millisecond.
Yep.
Is that normal for it to automatically go to like super fast speed?
It is not uncommon. One thing that I've done in the past when that's happened is there's a little bar, a slider over here by your simulator control panel.
Yeah. Is there a way to make it default slower or?
I think if you just drag it to slower, it's going to stay there.
Okay.
Let me just try here.
I just noticed that like as soon as I trigger that P1000 start, it immediately sets the alarm off.
I'm just going to look at my run feedback or my lifetime runtime variable there to see how fast it's incrementing. Yeah, so I'm 10 times slower than normal right now, I think. So it's 1 second since I started it. Mine seemed to be okay on the normal speed, but I have heard of people needing to throttle theirs back a little bit.
Okay. Could be because I'm on like 1.25. I haven't updated my Sysmac.
It could be, yeah. Actually, I only ever had that issue with older versions. I don't remember exactly which version, but yeah, you can control it there. You could also do things like step execution, which is really convenient for debugging. I know we've used the debugger a lot in the simulation, but we haven't really explored the features within it. So we can add breakpoints, we can do single scan executions, and we can do step executions. So I'll show you what step executions look like here. So if you stop your simulator and then go to step execution, it's going to start the simulator, but you are going to have to manually advance every step. And what's cool is it's not just one rung at a time, it's an individual step at a time, and you can change them before you get to them. I'm going to just set these. Now I'll hit the step execution button, and it shows you the order. So instead of going all the way to the right of the rung, it checked the contact below it before moving beside it. So that's kind of cool. And this will, you can literally individually step through every instruction, even when we break into a function block. I don't know if it's going to navigate me there. No, it won't. So if I go to, never actually tried this. Well, we'll see. Okay, so you can't step inside of your function blocks, but outside of them you can. I just learned that. Anyways, pretty cool feature. Sometimes things happen way too fast, even for the simulator to see. So it's definitely useful.
Yeah, that's really cool because even on the time elapsed data that I have showing, each execution of the rung is showing 2 milliseconds.
Okay,
you can actually see that the timer counting up by milliseconds.
Yeah, that is cool because that's going to be what your task is set at, right?
Mm-hmm. Yeah, exactly.
Good observation. Okay, guys, we're about halfway there, and I don't normally talk this much, so I need a drink. You guys can take a bathroom break, whatever you need to do. We'll reconvene about 10 after. If you have any questions, type them in the chat window, and I'll get back to them when I come back. Okay, we'll get going again. It's 10 after, perfect. So Adam made a comment isn't there an easier way to kind of auto-populate all these variables on our custom function blocks? And he's right. I touched earlier a little bit on UDTs, user-defined data types. They're called structures in Sysmac. They're just more commonly known as UDTs. So structures, UDTs, they're kind of going to be used interchangeably from here on in. So we'll go to our data section in our programming menu, and we'll go to data types. And I'm just going to delete this one. So we're going to make sure we're in the structures section, not union, not enumerated. And we're going to click and add a structure. And this will be our VFD underscore DT, VFD data type. So now what we're going to do is make a member for each of our input and output variables on our function block. So if you want to do this the easier way, you can undock the structures window by clicking on the tab at the top and just dragging it away from where it is. You'll probably notice as you mouse over the center of the screen, there's this cross, and that is how you redock it. So if you want to put it back to the way it was, redock it in the middle. If you want to do a split screen dock, you can redock it on either the top or the bottom. But for now, let's just leave it free floating. And then we can, I've got a fairly big monitor. Hopefully you guys can see the fine print there. But now I can see the input and output variables, and I can also work on my UDT right here. So the structure that we call VFD underscore DT, this is the data type, same as Boolean or integer. That's how we're going to refer to this as. So now everything we make from here on in is called a member. So we're going to create a new member, and we'll just work from top to bottom, left to right. We'll do the inputs first, then the outputs, and we'll match the data type of the inputs and outputs. So I'll start typing. You guys can play along. I'll pause for a little bit at the end. If you run into any issues, just type them in chat. I'm going to just comment a few of mine while you guys catch up. You optionally can do it as well. Oh, hey Brent, I just saw your message there. Yeah, we started. I guess, how far along are you?
I think I'm catching up now. I noticed that you created a new data type and you're adding members. Is that all I missed?
Yeah, basically. So just
Okay.
copy the ones I have here. You don't have to comment them. I'm just doing it to show you what that looks like when we actually start using them. But yeah, just make sure it's a structure, and then the first one you make is a new data type, and then on top, then you make members within that data type. So
Is there a quick keyboard way to add a member without needing to go right click?
don't believe so.
Okay.
I've Control C, Control V, a few of them, but no, I don't think there's a hotkey for that.
Okay.
I will put this off to this. Actually, you know what? I've got two Sysmac Studios open. I'll see if that's an option that we can assign a hotkey to.
I'm old school. I started in the DOS days, so I like keyboard shortcuts.
Good man, me too.
Okay, I'm caught up, I think.
Okay. Yeah, I don't think that's one that we can add a new one to with a hotkey. Okay. Yeah, sorry, not on that one. Okay, so we made our data type. Now I'm going to redock my window. So I'm just going to drag it over this cross that appears at the center, and I'm going to put it right in the middle. And now it should fall in line with the tabs that I have open. Okay, so now let's go back to our logic. And let's make two more rungs. And we'll make two more instances of the VFD control function block. This will be P3000 and P4000, we'll call them. Now we'll go into our global variables. And there's really two paths we could go at this point. I could actually modify my function block itself VFD control here. You guys don't have to play along with me at this point, but I could actually remove all of my output variables, all of my input variables, and just have one input variable that was, I'm going to delete this when I'm done with it, but I could make an input variable that was the, what did I call it, VFD data type. And this can be the main VFD data type input, we'll call it. And then from there, I could replace each of these with my main VFD data type dot start. I'm going to change this back, but that would be the quickest way to do it. And then it's just a matter of, show you what this looks like here. So just be a matter of taking one variable, mapping it to main VFD data type, and then everything is taken care of inside of it. So we'll go back to our global variables here, and we will create a new one. And the data type is going to be VFD underscore DT. And we are going to call this P3000. And I'm going to just cut and paste it and make one for P4000. And now when I'm entering my variables, I can go to P3000. I just start typing, I go P3, and it recognizes the VFD control variable that I made. I hit enter, and then I want to access one of the child members of this variable, so I just hit dot, and then here's all of the variables that I created within it. Stop, and you guys can just start populating these. They're all pretty self-explanatory here. When you guys are done that, you just change the name of this function block to P3000 VFB. We just can't have, yeah, there's a variable naming conflict there. I named the variable P3000 and I named the function block P3000. Then we can go up to here. You guys may not need to do this on yours. It's not too happy about something here. Okay. Yeah, so what I did there is it'll probably be easier to just let's see what would be the easiest way there. Let's see if this clears up a few. You guys don't have to follow along quite yet.
Stuart, it says
Yes.
that up in the variables that P3000 VFD is a data type VFD control. Is that correct? Like, why is it the same data type as the other ones? It's the name of a function block.
Yeah, that's
right. Okay.
That's right. Yeah, it's no. What I did is made two P3000s, and their tags were all identical. So I think it might be easier to just get rid of that guy for now. Let's go down to P4000. Trust me, it's easier to just delete the block when you do that. If there's a mistake to be made, I will make it in front of people. So don't use the same tag name as the block that has identical parameters. It confuses Sysmax. So let's just go down to P4000. Let's call this P4000 VFD. Let's make sure on our internals that updated. Let's delete the hanging instance of it quickly here. And I think we made a global variable for that. Let's see. Yes, P4000. That's better. That's got our comments on it, so we know we're pulling from the right variables now. So should be start.
Can I ask a question while people are filling in their tags here?
Sure.
Okay, I noticed that I made a typo when I defined the data type. One of my members I called run_RB instead of FB. Only I noticed it after I'd entered that parameter as my input to that block. So I went back and fixed the UDT, but it didn't update the renamed tag back here in the logic. So if I had used that in 100 places in my program, is there a quick way to do that global search and replace?
There is a global search and replace, but we changed an option on the other day. I don't remember which course it was. Do you remember going through our options and changing something?
That's right, yeah. So when we change something in the logic, it'll update the definition, or vice versa?
Vice versa, yeah.
Okay, so I just have to make sure I change it there before I go make the edit I just did.
Yeah, so if you go to your options, this option should take care of that. When changing a variable name on the variable table, change the variable name used in programs.
Okay, that makes sense. Thank you.
Yeah, no problem.
I like that you actually have control over that, because there will be times when you want one over the other.
Yeah, I would have had a default to changing it, but there definitely is a use for not changing it as well.
Hey, Stu,
yeah,
I kind of, oh, sorry, keep chatting there.
No, it's all right. Go ahead.
So I just did I tried this out, just copy and pasting a rung. So copy pasting P, 2000 to P4000. And then I did a find replace on the variables. And I was curious, I kind of missed the section where you could do that quickly. It's giving me an error that says that all of my variables aren't registered in the variable table.
Mm-hmm.
Is there a way to fix that so that they are?
Yeah, create the, so you I assume you went, if you cut a rung like this, and then you wanted to make a P5000, is that what you were going for?
Yeah, I was just trying to catch up. I missed the next step here, so I was just working on something.
Yeah, no worries. So what I would do there, cut and paste the rung, rename the function block itself, and then create your variable first for P5000. So we go down here, there's our, I'm just gonna paste the name for P4000, gonna make it P5000. Making sure it's the VFD data type there.
Okay.
And now they're created. So when you do your search and replace, you have it. Now, alternatively, I'll show you the other way to do it. So let's do a search and replace on this one. That has been a while.
If you just Control F, it opens it up.
And replace. Oh, it's a result pad. Okay. Control F, you said? Yes. There we go. So look at.
I did selection.
Yeah.
And then I just clicked on the rung.
So then we want to replace P3000. Replace with P. Or we're going to replace 4000 with 5000, right? So replace 4000 with P5000. Let's do our search. Yeah, so replace. Okay, so that checked out because I'd made the variable beforehand, or did it? Hold on, is this the error you were getting?
Yeah, that's the one.
The variable not registered in the variable table exists, yeah. So I think because search and replace did it, one thing we can do is you can just right click on it and just choose register in variable table.
Oh, okay.
That should take care of that. Let's just see. Yeah. So it looks like if search and replace makes the variable, it doesn't auto register it for you. So yeah, just right click on it, register in variable table. Okay, so anybody having any issues with that? I know I probably confused everyone a little bit with the P3000 block and naming my Udt P3000. Okay, good. Now, so the first thing we did here was the long way, manually, one rung at a time. The next thing we did was the quicker way, still a bit time consuming because you have to manually enter every sub variable that this thing needs. We just did the fairly quick way, which was make a UDT with all the members. So what we'll do now is the very fast way. I'm just gonna close my search and replace there. So go to our function block here, VFD control, and we're just going to copy and paste this VFD control function block in here. We can rename it, we'll call it UDT VFD control. The name isn't super important as long as it's unique. Now let's open that up. Expand our variables at the top. Now on our in-out variables, we are actually just going to have one variable. So we can delete, we'll just add it first. We'll create a new one. It's going to be an in-out variable. So this is where we use the in-out variable, because that array, that UDT that we're bringing in, has both inputs in it and outputs in it. So we need to be able to read and write from that chunk of data and just pass it through the block. So we're going to use the in-out parameter. The data type is going to be the one that we created, which is VFD_DT. And we'll name the parameter VFD UDT. And we'll just comment it. Now what we'll do is replace one by one all of the references to in-out parameters that we made in the first block there. So our VFD_UDT.start will replace our start. So go through your logic and replace them. We'll pause at the end, let everyone catch up. Okay, so is everyone good with what we did there? We replaced all of our individual bits and pieces of this function block with our user-defined data type and its submembers. So if anybody has any questions, speak up. Otherwise, just keep following along. Now we don't need all of these input and output variables, so I'm just going to delete them. Oh, a few too many. There we go. So now we just have one in-out variable, and it's our custom data type. All the variables inside of our block. I think I accidentally deleted a few there. Perfect. Okay, so now we're going to go back to our logic. We're going to add a rung. and we make a function block of our new custom function block that uses the UDT. So I called mine UDT VFD control. We'll give it a name. We'll call this P6000, I guess we're up to. One second. I think we need at least one Boolean on it. Let's try something there. Oh no, there it is. Add ENO. That's what we need right there. Sorry. So yeah, right click, go back into your custom function block with the UDT. Right click and choose add ENO. Trying something here.
Stuart, did you want that to be a Boolean?
Which one?
The enable that you just added.
Yes. Yeah, there's a extra step here I forgot, I think. That looks better. Okay. Sorry, yeah, we can't just have one input-output variable. We need at least an input variable. So I made one just called enable. It won't actually do anything. It's just a Sysmac thing. So just make an input variable. You can call it whatever you want. We don't even have to map anything to it. And just make sure it's a Boolean. Now we can add our, we'll add P6000. And I just made the variable as I typed it. I didn't go into the global variables first this time. And it automatically created P6000 and it made it the data type VFD underscore DT. So actually, I'll just put that on run. So now if I had a lot of VFDs in this plant, I can just come along P7000 VFD, make it a global, done. P8000, make it a global. P9000, make it a global, done. And of course, I'd go back and give each of these function blocks their own unique name as well.
Typo on the name, yeah.
Yeah. There we go. So there, Adam, you asked how the really fast way was. That's the really fast way.
Yeah, that's way better, man.
Yeah. And now if we had a few more hours, I'd show you how. But on the HMI, we can make an object. Well, I can kind of quickly show you how it works on the HMI. We won't have time to walk through all the individual steps, but on the HMI, I could now make an object that knew about those data types. And I cut and paste it for P6000, and I just tell it to use the P6000 tag. It knows it's the VFD UDT, and it's just cut and paste on the HMI as well. But we are unfortunately almost out of time. That took a bit longer than anticipated. Probably due to my mistakes that I've made before and couldn't remember how to fix. So,
I mean, yeah, if it would be worth it, maybe we could do another quick, hour brainstorm session on PID tuning, if that would be beneficial for people.
Yeah, like on another day.
Yeah, we could. I was hoping that, Adam, did you get the email I sent you?
Yep.
Can you open that program?
Sure.
Just tell me if you're able to. What version of Sysmac are you on?
1.40.
Oh, okay. Yeah, you should be able to open it then. I was hoping somebody with 1.30 that most of the other people here are using would be able to open it or not. I'm not sure.
How do you easily update your Sysmac Studio? Is there a...
There's utility.
Yeah, so in Omron, there is the Omron Automation Software Auto Update. Brings up somewhere. Brings up this. So we quickly check for updates for the installed Omron software you have. So I've got CX1 and Sysmac Studio installed. So it's going to just compare the versions that I have with the versions that are available for update. Now you do have to register for this. I don't think on the trial version you'll be able to. But that's something you guys can do because you've got full licenses. So yeah.
Is there anything else you want to share for today? I mean, we're already over time, so if we have more, then we should just schedule for another day.
Yeah, I really only wanted to go over PIDs, and I was hoping to give everyone this sample program just so, I mean, it's well documented enough that you can simulate it on your own and understand what's going on with it. So, but yeah, if we can't import it into 1.3, then I don't know if that's going to be worth it. But
well, we can test that in advance, and if it works, then we can schedule another session, and people can attend if they want to, or if they're not interested in it, then they don't have to. But I think
that being said, we're on 1.4 now, so if you want to get the full version, let us know, and then you can open this up and test it out just fine.
Yeah, for sure.
yeah, not sure how else I could do it without downgrading my software and transferring it through a PLC. Yeah,
let's just try that another time, Stuart.
Sure. Well, yeah, see if there's any interest in the PID stuff. Alternatively, you guys, you've got my contact info, you should, from the other courses. So reach out to me if you want to, if you have a PID application and you can't make the training or anything like that. I can walk you through it. Our PIDs are auto-tuned or manual. It's up to you, but it's easiest to do auto-tuning, in my opinion. So with that, there are a few other parameters that a lot of PID loops don't have, just to control the auto-tuning feature. But that's what I'm here for. So yeah, if the need arises, let me know. And if you guys think there's enough interest in a PID training session, we could probably do it in about an hour. So.
Yeah, and I've got some slides as well that Cal Coker presented, so that could add to the content of the PID session.
Sure.
That was my original idea for this 4th session, and you said you wanted to do it on intermediate programming. This was really valuable. But yeah, I think that would be great to do a section on PID.
Mm-hmm. Yeah, I think so too. There's so much I want to cover and not enough time. So hopefully this was useful to you guys. The custom function blocks are a huge time saver, especially when you pair them up with a custom data type.